So this lesson is about estimating limit values from graphs. My goal for you is to be able to estimate limits of functions using a graph. First, some new notation. We can talk about limits as x approaches a value from just one direction. These are one-sided limits. They look like little exponents, so this is the notation for approaching that value from the left or from the negative direction. As x gets closer and closer to that value, but still a little bit smaller, what's going on with the y-coordinate? And this little exponent of a positive sign means that we're approaching that number a from the positive direction, from the right, with x-coordinates that are a little tiny bit bigger than a. What's going on with the y-coordinates as our x-coordinates get just a little bit bigger than a? So those are one-sided limits. Here's an example of some one-sided limit questions. This first one is asking me for the limit as x approaches -3 from the negative direction. So that means my x-coordinate is getting closer and closer to -3, but it's coming at -3 from the negative direction. And it looks like what's going on here is that this graph, as x gets closer and closer to -3 in the negative direction, is approaching negative infinity. That graph is shooting down towards negative infinity. If I want to approach -3 from the positive direction, that means my x-coordinates are coming at -3 in this direction. And as my x-coordinates get closer and closer to -3, but are a little bit bigger than -3, my y-coordinates are getting close to 0. It's very important that you know that if these two limits do not match, so there's no match there, then there is no way for the limit as x approaches -3 to exist. So this does not exist because those two limits don't match. Challenge yourself to try to do the limit as x approaches 3 from the negative and from the positive direction, and then unpause the video so you can see my explanation of that. All right, if I'm approaching -3 from the negative direction, that means that my x-coordinates are a little bit smaller than -3, and it looks like my y-coordinates are getting closer and closer to 0 in that case. Did I say -3? My x-coordinates are getting closer and closer to +3 from the negative direction. And then as my x-coordinates approach 3 from the positive direction, my y-coordinates again are getting closer and closer to 0. These two do match. They're both the same number. And because that's true, then I can say, well, the limit as x approaches 3 is 0 then. Notice that it doesn't matter when we're talking about limits that there's a hole at 3, 0. That's okay. It's totally okay that there's a value at 3 that's somewhere else, because for limits, we only care what's going on if you're close to 3. Some of the limits that we talk about in this class just don't exist. So as x gets closer and closer to 0 of 1 over x, well, as if x is bigger than 0, then it looks like my limit would be positive infinity. If x is less than 0, it looks like my limit would be negative infinity. Since those don't match, this would be no match, does not exist. Okay. This one is similar, but these are not limits that are infinite. These are limits that if x approaches 0 from the negative direction, my y-coordinate is approaching -1. But as x approaches 0 from the positive direction, my y-coordinate is +1. And since those don't match, the limit does not exist. Another way that the limits could not exist is something called oscillation. So this is taking sine of 1 over x, but x is getting close to 0, so 1 over x is becoming infinite, and so we've got sine of infinity, and it turns out that the behavior of sine as you get closer and closer to infinity is really erratic, or it's hard to say what the value is for sine. So this limit does not exist because of that crazy oscillation. If you zoomed in on this point, if you zoomed in on the origin of this graph, you would see even as you get closer to zero, there's just no way to pin down where that limit is. So that's called oscillation. And so that limit does not exist. The other way for a limit not to exist would be if you're outside of your domain. So the limit as x approaches zero, well, if I'm closer and closer to zero, my function doesn't even exist. So if I approach zero from both directions, there is no function there. So because I'm outside of the domain, this limit does not exist. Sometimes the answer to a limit question is either positive or negative infinity. But in order to answer that way, make sure that you're approaching your number from both directions and you get the same kind of infinity. So 1 over x squared is this graph that kind of looks like a volcano. As x approaches zero from the negative direction, our graph is shooting up to infinity. As x approaches zero from the positive direction, our graph is shooting up to infinity. So this limit would be infinity. Similarly, this graph of negative tangent squared of x as x approaches pi over 2 from the negative direction is going down to negative infinity. As x approaches pi over 2 in the positive direction is going down to negative infinity. Since those are the same kinds of infinity, we say, okay, that limit is negative infinity then. We can also talk about limits as we go out to infinity. So as my x-coordinate gets closer and closer to infinity, so as I go out this way, what's going on with my y-coordinate? Sometimes that answer is numerical. Sometimes it is not possible to answer. But this particular graph, as x goes out to infinity, is going to go to 0. And here's sine x over x as x approaches negative infinity. So as my x-coordinates get closer and closer to negative infinity, or if they get larger without bound, I see that kind of oscillation, but it's oscillating slowly down and kind of bouncing down to 0. So this limit is 0 as x gets infinitely negative. Right, so that's looking at graphs to try to talk about limits, and that's where we are. Thanks so much.